Now, under the normal probability distribution, we have the standard normal curve. So what is a standard normal curve? The standard normal curve is a normal probability distribution that has a mean of 0 and a standard deviation of 1. So this is what a standard normal curve looks like. Again, the mean, median, and mode coincide at the center, which is again 0. And as you can see, the standard deviation is 1. Now, what are the numbers under our baseline? Now, the horizontal base contains the z-score values. Those are called z-scores. They are associated with the areas under the curve. Now, the area between z is equal to -3 to +3 is almost 1 or 100%. Because again, the curve almost touches the horizontal line or the baseline. Thus, there is a small fraction of the area under the tails of the normal distribution. So that is the standard normal curve. Now again, as we notice, there are some values under the baseline of our normal curve, which are again called the z-scores. So what are z-scores? A z-score is a numerical measurement that describes a value's relationship to the mean of a group of values. Again, the mean, median, and mode coincide at the center, and the mean of a standard normal curve is 0. Z-score is measured in terms of standard deviations from the mean. Again, the width of our normal curve is determined by its standard deviation. Now, if a z-score is 0, it indicates that the data point score is identical to the mean score. A z-score is a measure of relative standing. Now, how can we find the area that corresponds to a certain z-score? Fortunately, mathematicians were able to find the areas under the normal curve, and they have already been determined for our use. So, we have the table of areas under the normal curve. Now, by using this table, we will be able to find the areas between mean or 0 and a certain z-score. This table is also called the z-table. Again, the z-score represents the distance between a given measurement x and the mean. So what are the numbers inside our table? The row entries give us the z value, or the first two digits of our z-score. The column, on the other hand, indicates the 100th place of a z value or a z-score. Now, what are the numbers inside our table, or what are the entries in the body of our table? The entries in the body of the table give us the area or probability between 0 or the mean and a certain z-score. So those are the areas. Now, as you notice from the illustration of a standard normal curve, we have a negative or we have negative z-scores. Now, where can we find those negative z-scores? By the symmetry of the normal distribution, the area between z is equal to 0 and any point to the left is just equal to the area between z is equal to 0 and the point equidistant to the right. Therefore, the area from 0 to +1 is just equal to the area from 0 up to -1. Now let's have an example on how we can use the z-table to find the areas between 0 and a certain z-score. For example, we have to find the area that corresponds to z is equal to +1. Now, when we say the area that corresponds to z is equal to +1, it means that we're going to find the area between 0 or the mean and +1. Now, how can we use this table? Our first step is to express the given z value into a 3-digit form. Again, since we only have a one-digit z-score, we have to express it into three-digit form. Therefore, positive 1 will become 1.00 because we have to get the last two digits in order for us to determine which column we're going to get our area. For step 2, we have to use the z-table, or using the z-table, we have to find the first two digits on the left column. Again, the row entries give us the first two digits, or the z value. Now, the first two digits of our z-score is 1.0. Therefore, we have to find 1.0 in our first column, or the leftmost column. There we have 1.0. Now, our next step is to match the third digit with the appropriate column. Now again, our third digit is 0, or we have 0.00. So we have our column for our third digit. Now, what is the area that corresponds to z is equal to positive 1? Lastly, we just have to find the area, or the probability, at the intersection of the row and the column. Therefore, the area that corresponds to z is equal to 1, or the area between 0 and positive 1, is 0.3413, or 34.13%. So that is how we use the table of values, or the z-table, to find the areas that corresponds to z-scores.